Here are the solutions for the pre-calculus homework assignment, page 554, number 4 through 12. For all of these systems, you need to use Gaussian elimination to solve it. And for each transformation that you do, you need to draw an arrow and label the arrow with what your transformation was. Before I actually show the solution for problem 2, let's speak in general about how Gaussian elimination works. When you have a system of 3 equations with 3 variables, you can use Gaussian elimination to create row echelon form, also called triangular form, where the first equation contains all 3 terms, the second equation has no term in the first position and only has terms here and here, and the third equation has no term in the first or second position, but does have a term in the third position. That would create a triangular arrangement coming down like this, hence the name triangular form. It's also called row echelon form. To create that form, there is a 4-step process. In step 1, we need to have this term have a leading coefficient of 1. So in problem 2, it already does, but if it did not have a leading coefficient of 1, you have 2 options to create that. First, you can divide every term in the first equation by whatever that coefficient is so that it becomes a 1. And your second option is, if one of the other equations has a leading coefficient of 1, you can interchange the equations. Just make that other equation be the first one written. The second step of Gaussian elimination is to eliminate this term here. To accomplish that, you're going to add a multiple of another equation to that second equation so that this is eliminated. The third step is to eliminate this term, again by adding a multiple of another equation to the third equation. The fourth step is to eliminate this term. Once you've done all of that, that will create the row echelon form, also called triangular form, and then you can start doing back substitution to find the answers for z, then y, then x. So it takes a lot of steps to do Gaussian elimination, 4 steps just to create the form, and then after that, you still have to solve for the different variables. All right, let's tackle number 2. The first step of Gaussian elimination is to make sure that that has a leading coefficient of 1, and it already does. The second step is to eliminate this term right here. I observe that the first term of the first equation is positive 1x, that the first term of the second equation is negative 1x. These are opposites of each other. If we were to add them together, that would eliminate the x terms. So here's how I'm going to show this. I'm going to draw an arrow, and for the first equation, make no changes. For the second equation, I'll draw a transformation arrow, and on this arrow, I'll label what it is I'm going to do. I'm going to add equation number 1 to equation number 2 to create a new equation 2. And when I do this, I'm going to vocalize each addition term by term. And I would encourage you to do that as well. You don't have to speak out loud, but at least in your mind, actually speak it to yourself. That way you'll prevent errors. So x plus negative x makes 0x. There is no term here. Y plus 3y makes 4y. Z plus 2z makes positive 3z. 2 plus 8 makes 10. Next, I want to eliminate this term. I observe that this term is positive 4x. So if I added negative 4x to that, then it would be eliminated. To have an equation that has a negative 4x in it, I'm going to take the first equation and multiply everything in that equation by negative 4, because that's how this would become a negative 4x that when added to the positive 4x will eliminate. So I'm going to draw an arrow, And on that arrow, I'm going to write down what it is I'm doing. I'm taking -4 times equation 1 and adding that to equation 3. Now let's write down what we get when we do that. And again, I'm going to vocalize each step. -4 times x is -4x. -4x add 4x is eliminated. There is no x term. -4 times y is -4y. -4y plus y is -3y. -4 times z is -4z. -4z plus this blank spot is -4z. -4 times 2 is -8. -8 plus the 4 is -4. Here is our new system. It still has 3 equations, and it's not yet in row echelon form. The next thing we need to do to transform this system is to make this term have a leading coefficient of 1. How can we accomplish that? We can divide all of the terms in that equation by 4, because 4y divided by 4 would make 1y. So I'm going to draw an arrow and make no changes to the first equation. For the second equation, I'm going to draw an arrow, and I'm going to label on the arrow what it is I'm doing. I'm going to divide by 4. 4y divided by 4 makes y. 3z divided by 4 makes 3/4 z. 10 divided by 4 makes 10 over 4, or 5/2. For the third equation, I'm going to draw an arrow, and at this point in time, make no changes to it. Okay, over here on the right side is what our system looks like now. Again, we're trying to create row echelon form. So the next thing we want to accomplish is to eliminate this term. What could we add to -3y so it's eliminated? We would want to add +3y. Using the second equation that is right above it, what would you have to multiply this by so that this became a +3y? We'd have to multiply it by 3. So I don't have enough room to continue just going across in one line, so I'm going to come down to the next line on the paper and draw an arrow and make no changes to the first equation. I'm going to draw an arrow and make no changes to the second equation. And for the third equation, I'll draw the transformation arrow, and this time I'm going to label that arrow with what it is we're going to do. We want to multiply equation 2 by a 3, and then add it to equation 3. So 3 times equation 2 added to equation 3 to create a new equation 3. Let me vocalize that step by step. 3 times y is 3y. 3y added to -3y is eliminated. 3 times 3/4 z is 9/4 z. 9/4 z added to -4z makes -7/4 z. 3 times 5/2 is 15/2. 15/2 added to -4 makes 7/2. Now we've created row echelon form. Now we're not done. We haven't actually solved the system. We're going to solve this system by doing back substitution. Start with the third equation and solve it for z. So z will equal to 7/2 times negative 4 over 7, which is negative 2. Now that we know the value of z, we can go into the second equation and solve it for y. So we have y plus 3/4 times negative 2 is equal to 5/2. This means that y minus 3/2 is equal to 5/2. Y is equal to 5/2 plus 3/2, which is 8/2, or 4. Now that we know the answer for z and for y, we can do back substitution into equation 1 to get the answer for x. So we have x plus the y is a 4, plus the z is a negative 2, and that's equal to 2. Therefore, x plus 2 is equal to 2, so x is equal to a 0. We can take all three of these answers and write them in parentheses. This is called an ordered triple. Write them in alphabetical order. X is first, then the y, then the z. It's a good idea to check this answer using substitution because Gaussian elimination has so many steps, we could have messed up anywhere along the way. Okay, next, number 4. To use Gaussian elimination, the first thing we need to do is have this first term be 1x. I'm going to draw a transformation arrow and label that arrow with what it is I'm going to do. I'm going to divide everything in equation 1 by 2 and write down what it makes. 2x divided by 2 is 1x. There's still going to be no y term. 2z divided by 2 makes 1z. And 2 divided by 2 makes 1. At this point in time, I'm going to make no changes to the second equation. And no changes to the third equation. The next thing you do in Gaussian elimination is eliminate this term. There's two things that we could do. We could multiply equation 1 by negative 5 to create opposites and then add them together. Or we could interchange the second equation with the third equation. Because if we take that third equation and write it as the second equation, then it does not have an x term. Either one of those is fine. What I'm choosing to do is to add a multiple of the first equation to the second equation. So I'm going to draw an arrow and make no changes to the first equation. I'm going to draw another arrow, and I'm going to label what I'm doing on that arrow. Negative 5 times equation 1 added to equation 2 to create a new equation 2. Now let me talk it through. Negative 5 times x is negative 5x. Negative 5x add 5x is eliminated. There is no x term here. Negative 5 times nothing is nothing. And then when you add your 3y, there's still a 3y. Negative 5 times z is negative 5z. When you add the blank spot, it makes negative 5z. Negative 5 times 1 is negative 5. And negative 5 add the 4 is negative 1. I'm going to draw an arrow and make no changes to the third equation. Here's our new system. It still has 3 equations, but we're working our way towards row echelon form. I'm out of room on this line, so I'm going to come to the next line. For my first equation, I'm going to make no changes. For the second equation, I want this to be 1y. So I'm going to divide it by 3. 3y divided by 3 makes 1y. Negative 5z divided by 3 makes negative 5/3 z. Negative 1 divided by 3 makes negative 1/3. For my third equation, I'm going to make no changes at this time. Okay, the next thing I want to do is eliminate that term in the third equation. Now think about how we're going to do that. We need to add negative 3y to it. We can create a negative 3y from the second equation. If we multiply everything in the second equation by negative 3 and add it to the third equation, then we can get our y's to be eliminated. So I'm going to draw an arrow, and I am making no changes to the first equation. I'm going to draw an arrow and make no changes to the second equation. For the third equation, I'm going to draw the arrow, and I'm going to label the arrow with what I'm doing. Negative 3 times equation 2 added to equation 3 to create a new equation 3. Let's talk our way through that. Negative 3 times y is negative 3y. When you add 3y, it's eliminated. There is no y here. Negative 3 times negative 5/3 z makes positive 5z. When you then add the negative 4z, it makes positive z. I could just write a z here. Now the constant term. Remember what we're timesing by negative 3? Negative 3 times negative 1/3 makes 1. 1 added to 4 makes 5. We have created row echelon form, or triangular form. Now we're going to solve the system. Starting with that last equation, we've got the answer for z. Now we're going to do back substitution. We're going to work our way upwards. So now work with the second equation. Y minus 5/3 times 5 is equal to negative 1/3. This means that y minus 25/3 is equal to negative 1/3. This means that y is equal to negative 1/3 plus 25/3, which makes 24/3, or 8. So we have the answer for z, and we have the answer for y. To get x, let's go up into the first equation. X plus the value of z, that was 5, is equal to 1. Therefore, x is equal to negative 4. To finish this off, let's just write our answer as an ordered triple. The answer for x first, then our answer for y, then our answer for z. Because it's so easy to mess up Gaussian elimination at any step along the way, it's a good idea to check this answer using your calculator. Go back to the original system and look at the left side of the system and type it in the calculator, like 2 times negative 4 plus 2 times 5, and make sure it really makes a 2. Then go to the second equation and go 5 times negative 4 plus 3 times 8. Make sure it really makes a 4. And check the third equation as well. Here's the solution for number 6. The first thing to do is make this leading coefficient be 1x. So we can accomplish that by dividing everything in the first equation by 2. It will become x plus 2y plus 1/2 z is equal to negative 2. Okay, at this point, I'm not going to make any changes to the second equation. And I'm not going to make any changes to the third equation. Okay, now the next step of Gaussian elimination is to eliminate this term. This is positive 2x, so if we add negative 2x to it, that would eliminate the term. So I'm going to draw an arrow, and I'm going to keep the first equation the same. And draw a transformation arrow for the second equation, and on this I'm going to label what it is we're going to do. Let's multiply the first equation by -2 and add it to the second equation. So -2 times equation 1 added to equation 2 to create a new equation 2. Let's talk our way through that. -2 times x is -2x. Add 2x is eliminated. -2 times 2y is -4y. When you add this -4y, that's -8y. -2 times half z is -1z. When you add the 6z, that makes +5z. -2 times -2 is +4. +4 add the 13 is 17. Okay, on the third equation, let's think about how we can eliminate the 4x. We want to add -4x to it, which we can create if we multiply equation 1 by -4. So let's label that arrow. -4 times equation 1 added to equation 3 to create a new equation 3. Let's talk our way through that. -4 times x is -4x. When you add 4x, that's eliminated. -4 times 2y is -8y. Then add -2y, which makes -10y. -4 times half z is -2z. Then add the 1z, which makes -z. -4 times -2 is 8, and 8 add 6 is 14. The next step of Gaussian elimination is to make this term have a leading coefficient of 1. Just like how we started, we wanted our first equation to start with a 1. Now we want our second equation to begin with a 1. So I'm going to draw an arrow and make no changes to the first equation. And then draw an arrow here, and I'm going to write down what it is I'm going to do. I'm going to divide by -8. I'm going to divide all terms in the equation by -8. So that becomes y, and then -5/8z equals, and then 17 divided by -8 is -17/8. And I'm not going to make any changes to the third equation yet. Okay, let's transform again. I'm going to draw an arrow, and I'm going to keep that first equation the same. And draw an arrow and keep the second equation the same. And draw an arrow, and now let's transform our third equation. Let's think about how we can eliminate the -10y. We would want to add +10y, which we can create from equation 2 if we times it by 10. So we're going to go 10 times equation 2, add to equation 3 to create a new equation 3. 10 times y is 10y. 10y add -10y is eliminated. 10 times -5/8 is -50/8. -50/8 reduces to -25/4. And then we want to add the -1z. So we have -25/4 and -1, which is the same as -4/4. So this is -29/4z. Now the constant term. Remember that we're multiplying by 10. 10 times -17/8 is -170/8. Top and bottom both divide by 2, so this is -85/4. And to that we want to add 14. Well, what's 14 as a fraction that has a denominator of 4? It is 56/4. So negative 85 plus 56 makes negative 29/4. At this point, we've created row echelon form. Let's solve for z, then y, then x. Start with the last equation. Negative 29/4 z is equal to negative 29/4. Therefore, z is equal to 1. Take that answer for z and substitute it into the second equation. So we have y minus 5/8 times 1 is equal to negative 17/8. Therefore, y is equal to negative 17/8 plus 5/8. That's negative 12/8, which simplifies to negative 3/2. Now go to the very first equation and let's solve for x. We have x plus 2 times the value of y plus 1/2 times the value of z, and that's equal to negative 2. The 2 and the 2 cross cancel, so this is x minus 3 plus 1/2 is equal to 2. We can add 3 to the other side and then subtract 1/2 to get x equals 4.5. We have the answer for x, y, and z. We just need to write our answer using an ordered triple. 4.5, comma, negative 3/2, comma, 1. As always, grab a calculator, go back to the original system, and use your calculator to plug in the 4.5, the negative 3/2, and the 1 on the left-hand side, then push enter to confirm that you get negative 4. Check it into the second equation and the third equation as well. Here's number 8. Remember, the first step is for the first equation to have a leading coefficient of 1. We could accomplish that by dividing everything by 5, although that will create fractions. Or I notice how the third equation already starts with a 1. So we could interchange the first and third equation. Simply write the third equation as the first equation. So let's do that right now. X minus 11y plus 4z is equal to 7. Let's keep the second equation the same. And our third equation is now the 5x minus 3y plus 2z is equal to 3. The next step of Gaussian elimination is to eliminate this term. This is positive 2x, so if we add negative 2x to it, it will be eliminated. To make negative 2x, we can use our first equation, multiply it by negative 2, and add to the second equation. I'm going to draw arrows and on the second arrow label what I'm doing. So the first equation is going to remain the same. Oops, this is a y right here. It's that second arrow that I'm going to label my transformation. Negative 2 times equation 1 added to equation 2 to create a new equation 2. Let's talk it through. Negative 2 times x is negative 2x. Add 2x is eliminated. Negative 2 times negative 11y is 22y. And then add 4y is 26y. Negative 2 times 4z is negative 8z. And then add the negative 1z to make negative 9z. Negative 2 times 3 is negative 6. Negative 6 adds 7 makes a 1. Okay, my third transformation arrow. I'm going to label what it is I'm doing so that it eliminates the 5x. We can go negative 5 times equation 1 and add to equation 3 to create a new equation 3. Let's talk it through. Negative 5 times x is negative 5x. Add 5x is eliminated. Negative 5 times negative 11y is 55y. Add the negative 3y is 52y. Negative 5 times 4z is negative 20z. When you add the 2z, that's negative 18z. Negative 5 times 3 is negative 15. Then add the 3 is negative 12. Let's think about the next step in what we want to accomplish. Eventually, we want to eliminate the 52y. In the last few problems, before we did that, we would go to the second equation and we would make this be a 1y because that helped us in the next step to eliminate the 52y. But do we really have to do that? Do we really have to make this a 1y before we can eliminate the 52y? It looks like if we multiply the second equation by negative 2, that would make negative 52y, which would then add to the positive 52y to eliminate the y. I think that's more efficient. So I'm going to draw an arrow, and I'm going to keep the first equation the same. Draw an arrow here, and keep the second equation the same. Draw an arrow here, and then I'm going to write down on that arrow what it is we're going to do. Negative 2 times equation 2 added to equation 3 to create a new equation 3. Let's talk it through. Negative 2 times 26y is negative 52y. Then when you add 52y, it's eliminated. Negative 2 times negative 9z is 18z. 18z added to negative 18z is also eliminated. We end up with a 0 on the left side of the equals. Remember what we're multiplying by negative 2? Negative 2 times 1 is negative 2. Negative 2 add negative 12 is negative 14. In this problem, our third equation ended up being inconsistent. What does that mean? As with systems that have two equations and only two variables, when your algebra produces an inconsistent equation, that means the original system has no solution. Next, number 10. Again, the first step of Gaussian elimination is to have that first term have a leading coefficient of 1. So let's transform it by dividing all terms by 2. This becomes x plus 1/2 y plus 3/2 z is equal to 1/2. At this point in time, I'm going to keep the second equation the same. And keep the third equation the same. The next step of Gaussian elimination is to eliminate this term right here. So let's keep the first equation the same. And make a change to the second equation. We can go negative 2 times equation 1 and add it to equation 2 to create a new equation 2. Let's talk our way through that. Negative 2 times x is negative 2x. Add 2x is eliminated. Negative 2 times 1/2 y is negative 1y. Negative 1y added to 6y is 5y. Negative 2 times 3/2 z is negative 3z. Negative 3z add 8z is plus 5z. Negative 2 times a half is negative 1. Negative 1 add 3 makes 2. Okay, now our third transformation. Let's think about how we can eliminate 6x. By adding negative 6x, which we can create from equation 1. So our work is to go negative 6 times equation 1, add to equation 3 to create a new equation 3. Let's talk it through. Negative 6 times x is negative 6x. Add 6x is eliminated. Negative 6 times half y is negative 3y. When you add 8y, it makes 5y. Negative 6 times 3 halves z makes negative 9z. Negative 9z add 18z makes positive 9z. Negative 6 times a half is negative 3. Negative 3 add 5 makes 2. Okay, the next step of Gaussian elimination is to either make this be 1y or to eliminate this term right here. So do we really have to change this to 1y before we eliminate this? No, we don't. I'm going to draw an arrow and keep the first equation the same. And keep the second equation the same. And on my third arrow, I'm going to label what it is I'm doing. What would we add to 5y to eliminate it? We would add negative 5y, which we can create from the second equation if we times it by negative 1. So our work is to go negative 1 times equation 2, add to equation 3 to create a new equation 3. Let's talk it through. Negative 1 times 5y is negative 5y. When you add 5y, it's eliminated. Negative 1 times 5z is negative 5z, and then add 9z makes 4z. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. This is triangular form. In the last equation, we can solve to discover that z is 0. And now start doing back substitution. So in the second equation, we have 5y plus 5 times 0 is equal to 2. Therefore, 5y is equal to 2. So y is equal to 2/5. Now go up to the first equation, and let's get the answer for x. X plus 1/2 times the value of y, which is 2/5, plus 3/2 times the value of z, which is 0. And that's equal to 1/2. Right in this spot, the 2 and the 2 cross cancel. This becomes x plus 1/5 is equal to 1/2. So x is equal to 1/2 minus 1/5. That's the same as 5/10 minus 2/10, which is 3/10. As an ordered triple, our answer for x is 3/10, our answer for y is 2/5, and our answer for z is 0. Here's number 12, our last one. The first step of Gaussian elimination is to make that leading term start with a 1. We can accomplish that by dividing everything in the first equation by 2. It becomes x plus 1/2 y minus 3/2 z is equal to 2. I'm not going to change the second equation yet. And I'm not going to change the third equation yet. The more of these that you do, you can start to do more steps at one time, and that reduces the amount of writing that you have to do. The next step of Gaussian elimination is to eliminate this term right here. Because this is 4x, we could eliminate by adding negative 4x, which we can create from equation 1. I'm going to draw an arrow and copy down equation 1 with no changes. It's that second arrow where we're going to label what it is we're doing. Negative 4 times equation 1 added to equation 2 to create a new equation 2. Let's talk it through. Negative 4 times x is negative 4x, then add 4x is eliminated. Negative 4 times half y is negative 2y, and then you add the blank spot and it makes negative 2y. Negative 4 times negative 3 halves z makes 6z. And then you add the 2z and it makes positive 8z. Negative 4 times 2 is negative 8. Negative 8, add the 10, makes 2. Okay, now our third equation. How can we get rid of this negative 2x? We need to add positive 2x, which we can create from the first equation. So 2 times equation 1 added to equation 3 to create a new equation 3. 2 times x is 2x, add negative 2x is eliminated. 2 times 1 half y is 1y, and then add 3y makes 4y. 2 times negative 3 halves z makes negative 3z. Then add the negative 13z to make negative 16z. 2 times 2 is 4. 4 added to negative 8 makes negative 4. Next step, remember you have options. You could make this be a 1y, but you don't have to do that if you're able to eliminate this term without making this a 1y. And that's the case here. I think we could eliminate 4y if we added negative 4y to it, and there is a way to make this be negative 4y. So I'm going to draw an arrow, and I'm going to keep the first equation the same. And draw an arrow and keep the second equation the same. Although you certainly could divide everything by negative 2 and just have it start with a y. I'm going to draw an arrow and I'm going to label on the arrow what I'm doing. 2 times equation 2 added to equation 3 to make a new equation 3. 2 times negative 2y is negative 4y. When you add positive 4y, it's eliminated. 2 times 8z is 16z. And then you add the negative 16z, and that's eliminated. It just makes a 0 on the left side of the equals. 2 times 2 is 4. 4 added to negative 4 makes 0. The third equation creates the consistent equation 0 equals 0. This is not like the previous one where the left side and the right side were not the same and we said no solution. This time we have 0 equals 0, a true statement. There are going to be infinitely many solutions. So let's think about how we could record those solutions. To describe the infinitely many solutions, I'm going to say that z can be any real number. I'm using the letter A to represent any real number. Then I'm going to do back substitution like we've done before. Negative 2y plus 8 times A is equal to 2. Therefore, negative 2y is equal to 2 minus 8a. Then divide both sides by negative 2 to get negative 1 plus 4a. At this point in time, we have the value of z is equal to any real number, which we've called a, and we've described the value of y in terms of the value of a. Let's go up to the first equation and work with x. X plus 1/2, and then in parentheses, we'll substitute for y. We're going to substitute -1 plus 4a. Then we have minus 3 halves, and then in parentheses, we're going to fill in what we used for z. Remember how we were just using an a for that? And that's equal to 2. I'm not done finding x up here, and I'm out of room. So I'm going to take this piece and continue working on it down here. So we have x minus 1/2 plus 2a minus 3/2 a is equal to 2. What I've done is the distributive property, the 1/2 times to both things in the parentheses. Now I'm going to combine like terms with the a terms. So I have x minus 1/2, and then 2a, that's like having 4a over 2. 4a over 2 minus 3 over 2a makes plus 1/2a. And that's equal to 2. Now I'm going to add the 1/2 to the other side to get 2.5. And finally, to solve for x, I'm going to subtract the 1/2a from both sides. All right, here's what's going on. We said that there would be an infinite amount of solutions, and that z could be any number we want. And then based upon whatever the number used for z is, that would affect the value of y, and that would affect the value of x. So I'm going to write an ordered triple in parentheses. I'm going to do the x first. We have 2.5 minus 1/2a. Then comma, now the y. We have -1 plus 4a, comma, now our value of z, which is the letter a. I know this is really weird to see an answer like this, but it's describing the infinite amount of solutions to this system, all based upon any number you choose for z would allow you to find the answer for y, which would allow you to find the answer for x. Let's just do one example. Remember, there's an infinite amount of solutions. Let's just find one of them. Let's choose that a is 5. Then the answer for y would be -1 plus 4 times 5, which is 19. And the answer for x would be 2.5 minus 5/2. That's 0. Is 0, 19, and 5 really an answer? Let's check it in the first equation of the system. We'd have 0 plus 19 minus 15, and that really does equal 4. Does it work in the second equation? 4 times 0 is 0. 2 times 5 is 10. 0 plus 10 really makes 10. Do you think it works in the third equation too? And that's just one ordered triple, 0, 19, 5. That's just one answer out of an infinite number of answers. If we chose a different number for a, like 4, then that would give us a different value of y and a different value of x. And that triple of numbers would be a solution to this system.